That's it.
Alright. Is anyone grabbing lunch with us? We're gonna head back to the first years. You wanna give a round of applause to Farhan? We've got a recording of this as well. We're running through the maths exam you just did. Yeah. If you've got any questions, just
I'll be here.
yeah, let's go. How you eating that? I don't know. I'll let you know. Yeah. Are you coming or?
That's I thought too.
Oh, okay.
I'm like,
Yeah.
I mean, you can take
We'll
this.
still divide us.
Yeah.
Yeah. I'll message you.
Firstly, what I'll do, I'll send you guys the notes that I made. So just give me a sec. Math. Oh, shit. Is this first year here? Oh shit. Okay. So how'd you guys find the exam so far? Difficult? It is a pretty difficult exam. Give me a sec. How can I send it to you guys? Wait, let me check Instagram. Who's got a MacBook here? You guys have a MacBook? I'll just airdrop it to you guys, and then you guys can share.
Oh yeah, that's cool.
You guys can share it. Yeah. Who's iPad 100? Is that you? Okay. Who else?
How would you change settings so you can be in
I did, isn't it?
No, for me.
Oh, for you.
Top right control center.
Yeah.
Oh, mine. Yeah.
Okay. All right. Who else? Let me see now. All right. So good. Okay. Can you guys hear it clearly? All right. So the first question we have is: consider the plane P with Cartesian equation 9x plus 24y plus 20z minus 95. You guys are probably going to have different values. These are the values that Jared sent to me. So they've told us rewrite the above Cartesian equation as a parametric vector form with parameters s and t, which lie within the real numbers. All right. So these are questions straight from the lectures. The first step you guys want to do is let two of our variables. So I chose y and z. You can choose x, z, x or y. It doesn't really matter. Okay. So we're just going to choose them to be s and t. Okay. In the lectures, they usually do lambda 1 and lambda 2. Doesn't really matter. Okay. It's the same. We're just taking parameters s and t. Okay. So once we let y equal to s, z equal to t, we have to rearrange for x, and we get something like this. So we get an equation in terms of s and t for our x variable. Once we do that, we can just sub it into our vector x, y, and z, but we already know what y and z are. It's just s and t. Yeah. And from this over here, we can break it down into so what I'm going to do here, I'm going to say 0 plus s plus 0t, 0 plus t plus 0s. So I'm going to break it up into ones that don't have a parameter, so minus 95 on 900. Ones that do have a parameter, so one for s, one vector for s, and one vector for t. So we just take the coefficients of s. We have minus 8 on 3 and 1. And for our third row, we have 0. Alright? And this is the answer that we have. So if you guys got something similar, or along the lines, should be correct. The main thing you guys want to see, there should be 2 zeros over here, 1 0 here, and 1 0 here. Alright, did anyone get that correct when they did it? You guys all got it right? Hey, good to hear. Find a normal vector n to p. So I'm going to do this on the board. Hoping they can see it. Okay, I'll just do it here. So imagine we have a plane. So this is our plane P. Yeah? So we know there are 2 vectors that are parallel to the plane, or lie on the plane, right? So I'm going to call this over here V1 and V2. Right? The V1 and V2 we can find from our parametric vector equation. I'm just going to let V1 in our case be minus 8 on 3, 1, 0. V2, I'm going to let it be minus 20 on 9, 0 and 1. Yeah? Now, if you guys remember, the way we find a normal vector is by doing the cross product of the 2 parallel vectors that lie on the plane. So our n is just v1 cross producted by v2. Right? So this is the method that I use using the determinant. There's a formula that you can memorize, but I don't recommend it. And you can also do it on Maple. Yeah, doing it on Maple takes like 2 seconds to do it. All right. Oh, but to do it on Maple, you need a code. So you need to input this first one over here. So this one over here. So what this multivariate calculus does is pretty much just lets you do cross product, dot products, all of that stuff. All right. And then once you do that, you're just gonna do cross product of v1, v2, and that gives you the same answer that we have. Now for part C, I was going around and checking. I saw that Leo got it right. The best way to do this, you just want to sketch it, and then do a rough sketch, and you can kind of, how do I say it? Do a rough sketch, and you can visualize what our minimum D value is. All right. So, is there an eraser somewhere? Oh, shit. Okay. To do it, I'll do this on the board. So I've already drawn up a diagram here, but I'll try explaining it to you guys. So imagine this is our plane. You're looking at it from the side. So this is our plane. It's moving in this direction. We have a point that lies in the plane. We'll call this point B. What can this point B actually, like, what does it equal to, approximately? Well, not approximately, what can it be, according to our parametric vector equation? You guys can see the answer, but.
The x-intercept?
X-intercept, which one?
First, so negative 5 and 9.
No, alright. Yeah. So I'm just call it negative 95 on 9, 0, 0. So this is the one that lies on the plane. Alright? Then we found our normal vector, n. You can put this wherever. It can be here, here. It doesn't really matter. As long as it's perpendicular to the plane. Okay. And then we're also going to need to make one more point, point A. They've given us this in the question. So A is what, 20, 0, and negative 28. And I'm going to draw a vector AB, and I'll show you guys why I do that. So vector A. So taking a look at this diagram, if we have a point A over here, the minimum distance to the plane has to be the perpendicular distance. Right, if that makes sense. So it's going to be this perpendicular distance. So this will be our min distance. There's a few ways you can do this actually. You can use Pythagoras, or you can use projections, which is much easier. So what we can do, we can project our vector AB onto the normal plane. We will get this vector over here. This will be the projection of AB onto N. And then you can just find the distance of the projection. Because the projection will give us a vector. Just find the size of it. So I found the projection over here. BA or AB, doesn't really matter. You get a pretty weird number. I did it on a maple. You can do it by hand. It doesn't make a difference. All right? And then you just find the distance, which is pretty easy to find. So another way you could do this, d is equal to the square root. Actually, no, it's best if I don't do that. The best way to do this is just using the maple code. Yeah. If you guys want, copy it down. It would be pretty useful. This finds us our projection over here, and this gives us our normal distance. So I'll quickly write down. Okay. First question wasn't too bad. Alright. Can I move on? Yep. No. This question. Two colleagues, Fengling and Leslie, are given two vectors B and V, which lie within the 2D plane to work with, but they are only told that the projection of B and V onto B is 513. All right. Firstly, Leslie computes the exact value of the projection of 12V on B, not in terms of B or V. What does it have to be? Okay. Any ideas how we can approach the question? Leo?
Part A.
Yeah, part A. Any ideas how to do it?
You just multiply the original projection by the constant, which is 12.
Okay. Yeah, perfect. The reason for that is when you sub it into our equation, our dot product equation, you get 12v dot b divided by b dot b multiplied by the vector b. We can see that when we factor out a 12, we're left with v dot b over b dot b, and this is just the projection of v onto b. All right. So our answer is pretty much our original vector multiplied by 12. You might get a different number over here. It'll be 4 maybe, and your vector might be different as well. Your projection might be different. Nothing to be worried about. You just do, for example, if you had a 4 here and a 5, 12 here, you just multiply this vector over here by 4. Right? Okay, next. Part B. I'll actually give a bit of insight onto why it's going to be times by 12. Yeah, I'll do it after this part B. What do you guys notice for part B if you've done it?
It's the same.
It's the same, right? So over here we've got, oh shit. Over here we've got 60, 156. Over here we get 513. Right, we get the same answer. Now the reason for that, let's say this is our vector B and this is our vector V. If we scale our vector V by 12 times, so let's draw another one. Our original projection was something over here, like this. What is it? B onto B. Our new projection will be this thing over here, which is 12 times the projection of V onto B. You can use similar triangles to find it as well. Right? If you're not using the formula, you can use similar triangles. But however, for part B, I'll draw up the same diagram. B. If we scale our B vector by 12 times, so I'm going to do like a rough sketch. So this is what, 12 times B. What do you guys notice about the projection? So I'll call this projection of V onto B. What do you guys notice about the projection of V onto 12B? It's the same, right? This distance doesn't change. Because we're projecting essentially onto the same line. Right? Okay. This next one's a bit tricky. Did anyone get it? No? Did you get it? Okay, good. Anyone else? You got it as well? Alright, sick. I'll do it here. So I'm going to draw this similar diagram. So we have B, V, and I'm going to draw up a rough diagram for, what is it? Our vector is 7737 over 755. So maybe something like this. What we are trying to find is a projection of this green line onto B, which is, I'll draw in green as well. This thing. One way you could do it is you could chuck into the formula. If you chuck into the formula, we get something in the middle. Something in the middle. We get projection of V onto B plus the projection of 7737, 755 over B. We already know what this is. What is it? Oh, in my own. What is it? 513, yeah. 513, vector 513. When we try to do this, we don't know what our vector B is. So we can't just chuck into the formula again. We're going to have to use this diagram over here. So we've calculated the first part. This is the vector 513. But any ideas how to calculate the projection of the purple line onto our line B? So this is pretty much the projection over here. Any ideas?
You should replace B with the projection that's known already.
Why? Why do we do that?
It's in the same direction, it's just different magnitude.
Perfect. It's in the same direction, different magnitude. We saw from part B that the magnitude doesn't matter what it is. As long as it's in the same direction, we can use it as, to do the dot product. So we're just going to replace this B. So I'm going to say this is equal to plus projection of 7737, 755 of 513. And now we can actually compute that. Do it on Maple, do it by hand, whatever. Your answer should be something like this. All right. Quickly try it out for the people who couldn't get it and see if you get it right using how do I do button. Okay. Try it out. I'll give you guys like 2 minutes to try it out. Trace, you getting it? Making sense? Yeah, good. Hello. They all went to get lunch. Henry and Owen. Yeah. Oh, good. Maria, were you able to get it? Yeah. Yep. Alex, getting it? Okay. Can I move on? Okay. Move on. Now we get this long matrix question. So what's essentially happening is that we're making changes into our matrix, which what it does is that it changes our determinant value in a certain way. There are a few rules to row reduction over here. I wrote it down. So if you swap the rows, our determinant, you have to multiply by -1. If you multiply a row by a constant, you have to divide the determinant by the constant. Right? Wait, do we divide? Yeah, we do. Now, if you add rows together, however, our determinant doesn't change. Because essentially the matrix stays the same. And then when we get a lower zero triangle, what a lower zero triangle just means is that if you have a matrix like this, A, B, C, 0, 0, oh shit, 0, 0, 0, D, E, F. If we have a 0 down over here, a zero triangle, our determinant will just be the diagonals multiplied together. So in this case, our determinant will be A, B, C. Right. So in our case, let's analyze what we're doing to the matrix. So to get from this to this, what are we doing? What do we see? Are we swapping rows? Are we adding rows? Multiplying? What are we doing? Swapping rows, right? So we're swapping our first and third row over here and here. So we're doing R3 to R1. What does that do to the determinant? How does it affect it? Yeah, we multiply by -1. So in our case, our A will be -1 because we are multiplying our determinant by -1. Okay, to get from here to here, what are we doing? Okay, which row are we dividing by -3? Yeah, row 2, right? So what we're doing from here to here, we are doing row 2 is equal to -1 and 3, row 2. Yep. So in turn, what does that do to our determinant? Multiply by -3. Perfect. Multiply by -3, which is what we have over here. B is -3. Okay? Okay. Final row reduction. What do we do from here to here? What are we doing? Yeah, by a multiple, right? So we're just subtracting and or adding rows, yeah? And, one extra rule that I forgot to mention is that even if you multiply by if you add or subtract by a multiple of another row, our determinant stays unchanged, okay? So in this case, our C will just be 1, because our determinant stays the same. Final one, remember the lower triangle rule? Our determinant will just be all the diagonals multiplied together. Since they're all 5, it's just 5 to the power of n, which is our D value. All good?
Can I just look at all the rows?
Yeah, sure. Copy it down if you need. Damn. Oh shit, my bad. This is a pretty tricky question. Even though it's like the third question in the paper. Who was able to get it? No one? Oh, you were able to get it? Were you able to get it, Alex? Oh, nice. This is a pretty tricky question. Okay. Can I move on now? Yeah. Alright, I'll move on. So we've got an integral here where our f of x is given by this big whatever. Yeah, this big function. Now Sheen should find a simpler function g within our domain such that the limit of g f of x on g of x. What were the options for this, by the way? What were the different options?
That it exists and is zero, does not exist, or exists and is non-zero.
What do you think? What should it be?
Probably zero. It has to be existing.
It can't be zero. Yeah, 100%. But what else?
It has to exist.
It has to exist. How come?
Like, it has to exist in order to, that's how you decide whether something is, like,
Yeah.
by definition.
Yeah, by definition. It just has to exist. Alright. Alright. That's good. And explain why the limit of arctan of x divided by x plus alpha tan h of x is equal to alpha. Any problems? No. This you can just do by straight algebra. Alright. Chucking the limit here, since we have x on the bottom, this goes towards 0. Over here, what I did is I converted the tan h of x into a exponential format. And since this is equivalent to this, multiplying top and bottom by e to the minus x, we can just sub in infinity. This tends to 0, this tends to 0, and we're just left with 1. Alpha multiplied by 1, which is alpha. All good? Anyone need to copy it down? Right, let's continue. For this p-value over here, you can do any number, I'm pretty sure. If you try like 1, 2, 3, they should all work out. But always stick with 1. From what I've tested, 1 always works. Okay. And this q value, how do we find it? The way we find it is by taking a look at this function up here. Right? So we see there's an x up top, and our greatest power on the denominator would be x to the power of 4 times 79 over 114. Everyone sees that? Yep. So if we're trying to find the value of q, it's pretty much just x divided by x to the power of 4 times 79 over 114, by definition. Since this is to the power of 1, our q value will just be, I'll rewrite that. So we have, I think I've written it down here. Yeah, I do. Okay. It's because of this. On the top we have an x, on the bottom we have x to the power of 158 over 57, which simplifies down to this, which is p over x to the power of q. Right? Alright, sick. Oh, this one. I don't have solutions to this. Okay. Since, what are the options? Yeah. So p equals 1 over here, and q equals to whatever. I have it somewhere here. P is equal to 1, q is equal to this. Oh, so is it asking for convergence or divergence? Okay, so does it converge or diverge? Do you guys remember the converge? What's the rule? The limit comparison test. Right? Is that what it's called? Yeah, the limit form of the comparison test. since our q on the bottom is greater than 1, if we have an integral of 1 over x to the power of q dx, where q is greater than 1, our function f will converge. So we'll call this the limit form of the comparison test. Any questions? Okay. And as I said before, p can be any real number. It doesn't really matter. Okay. The reason I chose 1, because the simplest case up here, it can be 13 as well. It can be 7, whatever. Doesn't really make a difference. Alright, I'm going to move on to the intermediate value theorem question. So suppose a certain real valued function f is continuous along the function interval 31 to 44 and is also differentiable along that domain. Right? We know that the derivative of the function has to always be less than or equal to 81 between this domain. Okay? We wish to find an upper bound for f of 44. Wait, is it intermediate value theorem or mean value theorem? Mean value theorem. Sorry. It should be mean value theorem. Sorry, mean value theorem. Yep, sorry. Mean value theorem. Okay? So they've already told us that it's continuous along that interval and differentiable along this interval. By the mean value theorem, there exists, oh, by the way, this E just means there exists. There exists a C value within what? What domain? What am I missing here? Sorry? Wait, did I? What were the options for this one, by the way?
It's just I.
It's just I.
Like, it's not, there is only one C that satisfies that. It can't be for all C.
Yeah, okay.
It just,
There exists some C,
yeah.
Oh, is that it? Okay,
You've
so.
already like done, you've already answered.
Oh, I've already answered it? Okay, sick. So there exists some C such that this is true.
Yeah.
Okay, cool. I thought there was like some extra part here talking about the domain. Okay, cool. Alright, and they've actually showed us how to find the upper bound. So f of 44, this is using the mean value theorem. Mean value theorem. And you can just rearrange for f of 44. Alright. Okay. Now, using a similar argument, prove that f of 31 is greater than or equal to minus 480. So, over here, we're trying to find an upper bound. Over here, however, we're trying to find a lower bound. What I'm going to do, I'm going to use pretty much the same exact steps, okay? So we're trying to prove this, so this is required to prove RTP. Subbing into our MVT equation, f of 37 minus f of 31 divided by 37 minus 31. In your case, it might be a little different. So I just took this number over here and this number over here. This is equal to f dash of c, but we already know that this is less than or equal to what? 81, right? From what we have here. And then we're just going to have to rearrange for f of 31, and you get minus 4, greater than or equal to minus 480. These are for the values that I got. I'm not sure what values you guys got, so you guys are going to have to follow the steps and try plugging the numbers. So I'm trying my best to explain the steps, I guess. Value theorem. Was there an intermediate value theorem question in this paper? I don't think so. Yeah, that's all good. Next question. This one there, he give us a maple output. I'll do this part of it on the board. Okay. Consider a piecewise defined function defined by this, where a is some real number. We don't know what a is. We're gonna have to find it. Consider the maple output. Okay, what actually happened over here? What's going on? What are they doing? Why are we subtracting this function from this function? Oh, sorry, this function from this function.
Find whether they're equal.
Yes. Why do we want them to be equal?
Because we need to prove that at the point A, the limits of approaches left and right are equal.
Yes, that's what I wanted to find it. And easier way to say it, we're just trying to find the point of intersections. Alright? We're just trying to find the point of intersections. So x, y. And then when we factor, we get two values. So the two values a equals to p1 and p2 make h continuous. Okay? So for example, let's say on the left-hand side, right, we get that cubic function. Doesn't really matter what it looks like, something like this. Yeah. And we say this is a. And then on the left-hand side, we have, or right-hand side, we have our linear function. So it will be going up this way. And we're trying to find what a is. Okay. Originally, let's say our function looked something like this. And something like this. Alright, so this is the linear function. And this is dq. Because of the discontinuity, because of the piecewise defined function, right? When we let them equal to each other, we find the point of intersection. And what that does, it just connects the two ends together, makes it continuous. Right? Even though it's continuous, is it necessarily differentiable?
No.
No. Right? So if it's differentiable, so it's continuous if they pretty much just meet, or as you said, the limit equals, the limit on both sides approach the same value. Yeah, that's perfect. That's what the continuous, that's how you define continuity, right? But differentiability, the gradient at this point has to be the same on both sides as well. Okay. So pretty much the limit as x approaches a minus of f of x, f dash of x, has to be the limit as x approaches a plus of g dash of x, g dash of x, sorry, g dash of x and f dash of x. Yeah. Okay. Observe the h is differentiable everywhere. Okay. When is this true? When is it differentiable everywhere? For both values? For no values? For maybe one value, not the other? What might it be? Hands up for both values of a. Hands up for no values. Hands up for only one value. Why?
I just substituted it together.
Yeah, good. Yeah, you're just gonna have to find h dash. So in my case, I'll just say that h dash of x is equal to, what is it? 6x squared. Yeah. And you just follow the same steps. You find the point of intersection, and what you see is that only one of them matches with what we have. So before we had 19 and 4, But in this case, we have 14 and 4. So it's only true for one value of a. You guys see that? Okay. Okay. Alex, we just went through this one question. You want to go through it again, or
Oh, no,
were you able to get it? Okay, good. Okay, next question is complex numbers. Who's confident with complex numbers? Sorta? No? If you did 4 unit in high school, I think it might help a little, but not really. Okay, so our polar equation that they gave us is e to the power of 34, or e to the power of 3 over 41 multiplied by theta. Right? So essentially this curve goes on and on and on and on. But they've only given it between 0 and 4 pi over here. So and what we're trying to prove is that this complex number lies somewhere on the line here. Yeah? So the way we can do that, first of all, find the general equation of the curve. So in terms of theta, right? We're going to parametricize in terms of x and y. So we got r cos theta and r sin theta, which is just by definition, right? And what essentially happens is that because z is equal to x plus iy, once we have our x and y polar coordinates, you can just sub it in here. Yeah, polar equations, whatever it is, yeah? Okay. And we see something interesting when we kind of factor out the z they've given us here. This is just by pure intuition, okay? So if you don't see it, you're probably not going to get it. But if you do see it, you'll see that cos of the root 3 on 2 and the minus a half. If you sub in theta is equal to minus pi on 6. Yeah? So if you guys have seen e to the I theta is equal to r cos theta plus I sin theta. If you sub in e to the, if you sub in theta equals to minus pi on 6, you get r times root 3 on 2 plus, minus I over 2. I'll do it like this. Yeah. This is a pretty useful identity. Another one is if you have e to the I pi on 4, you get r times 1 over root 2 plus I over root 2. So we can see that if we sub in theta is equal to minus pi on 6, in fact this thing over here, our r value, also becomes negative pi on 82. Okay? So our reasoning is pretty much the complex number z lies in the Argand plane when theta is equal to minus pi on 6, which is somewhere over here. Minus pi on 6, minus pi on 6, somewhere here. Hello, bro. Hello, bro. Okay. Hey. Does pi A make sense? Maria, pi A?
Oh, yeah.
Hello, bro. Fuck, everyone's gonna be watching now. Leah, pi A make sense? Nah? Alex? Sure? Okay. Trace? Hello, bro. Trace, pi A make sense or no? No. What do you need? What does it make sense?
every day.
Sorry? Why is it not just pi? So if you sub in, back to this equation over here. If you sub in just pi on 6, right? You end up getting. Now we go. But this becomes I on 2. So this plus. But what we're looking for is a minus of that. Stress, what do you need to explain? Sorry? It's tired. Oh shit. Okay. Okay, part B. Select all that apply. Okay, I'll just pretty much go through why these three are true. Okay? So there exists some z which lie on the curve, but z conjugate which doesn't lie. So consider z over here. Yeah? So something that looks like this. If you take z conjugate, it will just flip across the x-axis and you get something over here. Does this line the curve? Yes or no? Does z conjugate line the curve? No, right? So this has to be true. Oh. Okay. Now, the circle with radius 23, so this is just does anyone know what this is in terms of polar coordinates? You know? Polar coordinates. So, do you guys remember the formula? Oh, I didn't say that. R squared equals x squared plus y squared. So essentially we're just letting this be 23 squared, and therefore r equals 23. So this is polar equation of circle with radius 23. Something to remember, okay? Do you guys remember where this comes from? Yeah. So we can drop the circle here, or r is equal to 3. So if r is equal to 3, we get something like this. That's just r equals to 3. And it just goes all around the circle. And there will be unique solutions, obviously. Okay? So if we have z is equal to e to the I theta, therefore z to the power of n will be e to the I n theta, right? So if we have, let's say, z to the n here, what will happen if we take it to the, sorry, if that's just z, if we take it to the power of n, where is it? As you increase your power to the power of n, right, it will just slightly get larger, 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 but it'll always line the line, if that sort of makes sense. So if that's z, let's say this, for example, is z to the power of 5. Something like that. You can sub it into this equation to check. Okay. Last question over here, we have to find the gradient. Okay? What's the formula for a gradient, by the way? Rise over run? Yep. In terms of derivatives. So if you have a function y, so they've taught us, if you have a function y with respect to x, how do you find the derivative? dy dx, right? At point. So when you set in a point, we get our value for n. Okay? The only problem is that we have x in terms of theta. Yeah. So what rule do we have to use to find dy dx? Chain rule? We're gonna have to use chain rule, right? So dy of dx.
Oh. Yeah, you don't need it. But the email's the other way around.
Oh, yeah. I was like,
And then after you find this over here, x equals to what value did they give us? Oh sorry, they gave us theta. So theta is equal to pi on 4? Yeah, pi on 4. So I've done it for you guys here. So over here we're finding dy and d theta. You're gonna have to, unfortunately you're gonna have to use the product rule because our r is in terms of theta as well. Right? We have it here and here. If our r wasn't in terms of theta, then dx on d theta. We can't do that, okay? Because our r is in terms of theta as well. Then we have dx on d theta. Just divide both of them, you get something like this. You might get something that looks a bit more disgusting, but this is what I got, okay? After you get this, they've told us theta at pi on 4, and after you sub it in, you get m is equal to this. You should get a negative value, by the way. Unless you get a positive value. Oh, it depends on your graph. So in my case, pi on 4 exists somewhere here. If we take the tangent at that point, we see that our line has a negative gradient going downwards. Alright, so this is Trace, does that make sense? The negative gradient part? Sort of? Alright. Make sense? Makes sense? So far, sort of makes sense. These questions are really hard. Okay. So luckily in part 2 they didn't tell us to redo the whole thing. They've only asked us for the procedure. Procedure is main steps to show that the tangent at A, which is this one over here, the tangents at A and B are perpendicular.
Yeah.
So we already know what the tangent at A is. Is that? All we're going to have to do for tangent at B, use our same dy and dx, just sub in our different theta value over here. Oh shit. So already done. And then pi 4, which is what I've done over here. And I've added some calculations. So, Leo, were you able to get this question over here?
If you were only unbalanced graph.
I mean, after I sort of done the first part, and then, yeah, afterwards, yeah.
Okay, good.
There's no way it goes wrong.
So pretty much what we did, we found dy and dx using our chain rule, and then yeah. The procedure is that we find the same dy and dx. You don't need to redo it since we already have it from part 2. And then sub in our theta equals to minus pi on 4. And if you guys remember, m tangent is equal to, so our m tangent is equal to minus 1 over m perpendicular. Okay, sort of makes sense. The last part makes sense? All good? Okay. Okay, this question. Okay. So OR is what we have here, and OT is here. What we know for sure is that they're not parallel. They're not parallel. Because they meet at one point. Obviously parallel lines never meet. Okay? And also they're equal in magnitude. You can just C by looking at R and T. Okay. So we can say that size of R square root of 50. 58, and then which is equal to size of OT. Yeah, so they're equal now. So we're going to be checking these two boxes. This question was pretty easy. All you have to do is find RT and OS. RT, we can just do. What is it? Yeah. So RT is just OT minus OR. And OS, we can take a look at our diagram here. The way we get to it is OT plus TS, right? But our TS is also equal to OR. So we can say TS, but Leo, is that all good? Okay. And then you sub it in, you get 10, 10, and minus 4 minus 4. Also, by the way, so what we did is we just found the diagonals, right? Are these diagonals perpendicular or not? Are perpendicular. How come?
The diagonals of
Rhombus. That's one reason. In a mathematical way. Why? It equals to 0. Yeah. So over here, we observe that the dot product is equal to 0. And because it's equal to 0, that means our diagonals are perpendicular. Right. One thing to always remember is that the diagonals of a rhombus is always perpendicular. Okay. Hence, Mira concludes that the diagonals of this and this are perpendicular. Alright. However, Chris is unsatisfied, blah blah blah. Okay. So the points BACD. So I'm gonna draw this up. Yeah, B, A, C, D. So what we see is that BA and DC. Wait, give me a sec. BA and DC. The vectors BA and DC are what? Parallel? Oh, sorry, adjacent. Sorry, they're met. BA and BD, the adjacent sides, right? And so are what? Which are the other lines that are parallel? Adjacent. Sorry. From the diagram that we have. So we know that these two are adjacent because they're touching. What else? AC and CD. Yep, that's one more. How about anything else? BDDC. Yep, I think there should be one more. AC and AB. Yep. Oh, we really don't need it over here. Okay. Okay. So taking the dot product of the diagonals, what they've done is that they've broken up BC in terms of BA plus AC. Right? And they've broken up, what is it? AD in terms of AB. And what is the other one? AB and BD. It is this one over here. However, this should be what? BD is equal to minus DB? Yeah, it's over here. And what's this meant to be over here? What are the options? Oh, maybe this one's meant to be here. And then what's this meant to be? Oh, you guys have different choices. That's right. Hey, that's what we. Okay. I'll quickly go through it then.
A, D, C, D, and
Yeah, that sounds correct. Yeah. So what you're trying to see is that you need to flip one of the signs in order to cancel out terms in our dot product. Okay. So you see it over here. As you go down, our BC dot AD is equal to 0. So that's the second proof of how to show. This is a general proof of how to show the diagonals are perpendicular. Alright. And part C is the same thing. Okay, we don't need to go through it. It's the same shit. You can just follow what we have over here. Okay, can I move on? I think that was one of the more easier questions compared to the rest. Okay. I'm going to skip this question because it's pretty cooked and it requires induction and some other stuff. So I'm going to skip it. I'll come back to it. Okay. Were you able to get that question? Yeah.
no, that's like the one I was like considering leaving, but I was like, I wait till we do that question.
Yeah, I'll come back to it. You want me to go through it now or? 'Cause it's a pretty long question. I feel like we should go through the other more important questions first. Because this is like a bunch of just algebra bashing. Yeah. Alright, question number 10 or 11. What are the stationary points of F? How do you find stationary points? Pretty easy. Derivative that equals to 0. Huh? You can do this on maple. So, where's my maple? I've lost it. Hey, never mind. I don't have maple. So, because it's a cubic, I can't really do it by hand. So you just do it on maple, and you get 3 values. The values they put out for me was -4, 0, and 8. Okay. Which of the following intervals is the range of F? Why can't it be all? You okay? This happened twice today. You okay?
Yeah.
Okay. Why can't it be all real values, by the way? Sorry? Why can't it be all real values?
Well, if it's a quartic, it will always go up on both sides.
Perfect. That's one way to think about it. It's because it's a quartic. That's what I was trying to get at. So since it's a quartic, my graph would look something like this. So it'll either look like this or it'll look like this. And there will obviously be values up here which aren't included in the range. Okay. So values down here. In the range. Okay. So how do we find the values that are in the range? Okay. One way to do it is that we know we can find this minimum point here. Or here. No, we talk about this. This is the global minimum. How can we find the global minimum, by the way, or the y value of the global minimum? Yeah.
You just put it in,
So yeah, that's the definition of the global minimum. Yeah. But then
plug it into one of those points. If you either it's either plugging into -4 or 8, but it won't work with 0 because you go down and down.
Perfect. So
So you only need to test 2.
So it can't be this, because it comes back up. So it's either -4 or 8. So just trying out both of them. You can also put it into maple, right? So into maple, you'll get either, in my case, I got C minus 8,192. So this is for x equals to 8. Or you get C minus 1,8. So which one would be the minimum value, the true minimum value? Global minimum. So you can already see on the board, it's part A. It's this one over here. Because it just goes lower more. If that makes sense.
You can't do that without testing your math though, right?
Sorry?
You have to test both points though.
Test as in,
Like you have to plug -4 and 8 into the equation.
yeah. That's what I've done here. So I'm just plugging them both in. I did it on maple. So a minimum value occurs over here with a minimum value of negative C minus 8,192. And it goes all the way to infinity. So from this point, all the way to infinity. Alex, you look kind of confused in this one.
Oh, no, I get it.
You get it? Sure? Okay. Leo? Shreyas, you lost? Just a little? You good? Alright. Okay, for part C, you're just gonna have to use the formula. Use the formula that we use. All good? Yeah. Copy this down by the way, if you haven't. Do you guys want like a 5-minute break? Do you guys want like a 5-minute break? Smoker? 5-minute break to cool your brains. Yeah, Alex, you want a 5-minute break? Or you want me to keep going and finish it off?
Oh, yeah.
I'm fine with finish.
Alright, finish it off.
That's your
You want a break or not? You want a break? You want a break? Would you like a break? Fine. Unlucky, mate. We're gonna keep going. Nah, I'll give you guys a break because I need a break as well. So, take a break. Take a 5-minute break.
Yeah, it's fine. It's good.
How is this guy? No, it's good. It's good. Yeah.
I don't think you signed up to that.
Oh no, I'm buying
You're playing too much. Is that how easy it was?
Yeah, I know, right?
Yeah, that's a fair. Let's see.
I think I'm bummed by that. Knowing what fucking maple pull out is.
Have you had it?
Yeah, that's right. I've never
I just came to still not wait through.
Whoa. Yeah, like true.
Max, but during the exam, they just say, sure.
No, fucking that's a wonderful. Whoa.
Okay, I'll go.
Figure out where
So what you know, like
We've got 3 more questions left.
Thanks a lot. It's like
we've got so much time.
Why are you doing something? I want you to try it. Because I had it.
While you were grinding.
I'm really bad at making it. Every time I know you choose that.
Like the commander.
I accidentally did the one. While you've been marking this, I've been trying to read for him. I did the whole
The one that I can't have.
What? Oh, okay. Oh.
You got the fourth turn. Outside. Are you gonna
Yes.
we should make some more with that.
and the M&M.
Yeah.
Just need a fire. Didn't have to set fire to something.
Okay, guys. Who else left? Maria.
Yeah.
I'll just send it to them afterwards, okay? Hey, part C. Leo had a weird way of doing it. Leo, what'd you do? Did you just chuck into maple?
Yeah.
Okay.
It's a long ass like question.
Is it? Okay. Yeah, so this is all you have to do, by the way. So we're taking the derivative of the inverse. So. D on
Yesterday was fine.
the inverse of. That's a general formula. Okay. Part E. I was gonna do it with you guys. Where's my pen? I've lost it. Thank you. I saw the mark here, I'm like, there's no way. Okay. Guys. So what we have is we have a quartet, right? So it is possible to have 4 solutions. 1, 2, 3, 4. But however, because of C, if it's negative, it will move down. If it's positive, it will move up. So if C is a very, very big number, such that it doesn't touch the x-axis, how many solutions do we have? 0 solutions. Perfect. So if it's somewhere up here, yeah, it doesn't touch the x-axis, we have no solutions, right? However, it's also possible if C is very, very small, very, very negative, very large negative number, right? How many times will it touch the x-axis? Twice, right? Because something like yeah. What's going on? What's going on?
All good.
Oh, good. Makes sense. Okay. So. Can it ever have 3 solutions? Yes, it can. So, for example, where'd my pen go? If you have something like this. That's 3 solutions. Right? So it bounces twice in the x-axis. So we've already discussed that it may have no solutions. Why is this one wrong? Perfect. Exactly. Alright. So it does have 4 at some point. Hey, let's finish it. So you just want to pretty much visualize all the possible scenarios and then chuck it in.
I think the third one's probably wrong. Yeah. Because it needs to be in the range of the function itself.
What's the range?
And for the entire range of the function, there will be at least one solution.
Yeah, so if you let your range, if let's say C is equal to 0. So the red one that I'm doing here.
Why? Because I was that much of a challenge.
Can you check your solution if it's
Yeah, because once you tip that one, it becomes yellow.
it becomes yellow.
Yeah.
But everything else is correct.
Yeah.
I love how my name was
Oh, yeah.
But if we do that, our range becomes somewhere down here.
Yeah.
Are you sure? Oh wait, are you talking about this one?
Yeah.
Oh yeah, sorry. Yeah, you're right. Because at that range, sorry, there has to be at least one solution. Sorry. So it is possible to have no solutions, but because of the range they've told us, right? Because of the range.
Oh, I know what? Because he said seller, I looked up.
Is C a positive number? It's just a real constant. It doesn't really matter. Yeah, good pickup. Yeah, you can even plot your graph on thing. Try out different C values. Okay. Can I move on? Okay, beautiful. Question 11. So we have x1 multiplied by vector v1 plus x2 multiplied by vector v2 and x3 multiplied by vector v3 is equal to b. So our vector b is what we have to the far right. Okay. How do we find the matrix A? What's the matrix A? What is our matrix? Trace? Any idea? Sorry? Yeah, that's pretty much it. So, yeah, so that's what Alex said as well. I'm going to put it something like that. Right. So our matrix, oh sorry, I should probably get rid of this. So this is our matrix A. Vector v1, v2, v3. Okay. Suppose there's only one unique solution. Okay. Do you guys remember what it means to be a unique solution in terms of matrices? Sorry? Are you talking about the zero triangle?
Yeah, that's fine.
Or yeah, pretty much. You can just say that. Has all leading columns. Yeah. So pretty much if you have A 0 0 something B C 0 G. So yeah, one way you can say is the zero triangle. But this is the formal definition that you we use the zero triangle more for determinants. So it has all leading columns and it's a square matrix. If it's not a square matrix, there are problems. Because you might not have all leading rows. Okay. So what are square matrices? Anything in this form, n times n. So you get 2 times 2, 3 times 3, 4 times 4, all etc. Okay. Now suppose we have infinitely many solutions now. Okay. Now will our equation here have 0 solutions, infinitely many, or a unique solution? Infinitely many? Yes. How come? Okay, yeah, that's one way to say it. What do we notice about this equation here? If we form a matrix, so what this matrix is just R3 plus R2 from our matrix here, because we're doing R3 plus R2, right? You guys notice that? So essentially, the matrix is staying the same. Yeah? We're just doing row reduction. So since our matrix is staying the same, and our original matrix has infinite many solutions, how many solutions will this matrix have? It's the same matrix, right? So how many solutions? Infinite. Perfect. You have infinite many solutions. Because it's the same matrix. Okay. Hey. Last part. Part D. Suppose that it has no solutions now. Okay. Will it have no solutions, infinitely many, or unique? Any ideas? Hello. Okay, so let's say what we're solving over here is A. Oh, sorry. You guys see that? So it's just a matrix A multiplied with the vector x is equal to 0. But what we had before is the same thing. Yeah? So one thing to note, so either the equation has infinitely many solutions or no solutions at all. Because of what they've given us. Right? Because of that, since there are non-leading columns present. Okay? Why do we have non-leading columns present? Because it has no solutions. Okay, so we've discussed for unique solutions. For unique solutions, it has leading columns. For no solution, but the zero vector is a solution, which is what they've shown us here. An equation to the solution is if the x vector is equal to 0. Okay? So that means it does have a solution. Then therefore it can't have no solutions. Make sense? So out of the two, which one does it have to be? Infinitely many solutions. Perfect. Trace, you look lost. You want to re-explain it? You're lost. You want to re-explain it? Okay. Yeah, matrices is a pretty difficult topic. Okay. Question 13. Can I move on to it? Consider the function f of x is equal to cos to the power of nx. Let's do it real quick. Okay, yeah. What is the constant term in our expansion? They've told us two things. They've told us that any positive power of cos x can be expressed as a sum of cos kx, and the same thing with sine. Right? Before I show you guys the solution, any ideas how to do this? No? No? Have you guys thought maybe using complex numbers? Yeah. You're gonna have to use complex numbers for this one. So this is what we get. Okay? So we can express our cos term in terms of exponentials. E to the power of I theta plus e to the power of minus I theta. And then, since it's to the power of n, you're going to have to use the binomial expansion. Alright? That's what we get over here. This is what we call the binomial theorem. Binomial theorem. And if it's a constant term, that means we want this to cancel out with this. Does that make sense? So let them equal to each other, and we get k is equal to n over 2. And you can see when you sub n over 2 back into k, you get and they cancel out. And you're left with a constant term, which is n choose n over 2 times half to the power of n. We can rewrite this as Part B. Briefly explain why g of x may be written as a sum of multiples of terms of the form sine kx. So I've got a pretty long explanation here. So we know it's even, and we know that it can be written in terms of cos mx, which is what they've told us up here. Or cos kx, it doesn't really matter. Okay. So we can also rewrite our sine in terms of sine kx as well, which is what they've told us here. Where is it? For any odd powers, so in our case we have 613. Alright, 613. We can rewrite that in terms of sine. So we can say sine 613, x is equal to maybe sine x plus sine 3x plus dot dot dot. Yeah. Now, when we multiply the cos and the sine terms together, we get something in this form: cos mx times sine nx. Oh, okay, nx, yeah. And have you guys seen this formula before? Product to sums. You guys might have seen it in high school, might have not. Did it not cover this in the lectures? Product to sums. No? Okay, I'll quickly pull it up. These ones are good. You guys might want to copy it down. Yeah. So in our case, we're using this one over here. So our mx, m plus n, m minus n. All good? Okay, so in other words, since we can break it up into sine, our g of x we can rewrite in terms of just sine, kx, where k is equal to either m plus n or k is equal to m minus n. I'll leave this up for a sec. Wait. And this is the full explanation. Okay, I'm hoping it doesn't. Got that on camera. It's recording. All right. This is more intuitive. Okay. So if you haven't seen the product to sums, then it's going to be a problem. Okay. I forgot your name. Yeah, you. No, what was your name? That's the question. Anushin, okay. Does this make sense?
Yeah, I got wow. I just got the first bit.
You got the first bit?
Yeah.
So this part over here. Have you ever seen this before?
Yeah.
Yeah. So it sort of makes sense.
Yeah.
Okay. Leo,
Yeah, we're good.
we're good? Okay. Alex, still confused about this one? Oh, you got it now? Okay, that's good. Okay. Now, part C is a bit cooked. Okay. What? Wait, laughing. This is the one that we went through. So, sine kx will go to 0 for odd values of k. And if k is odd, we know it's either in the form 2n plus 1, I'll just do 2j plus 1, or 2j minus 1. Why is that the case? Why is it 2j plus 1 or 2j minus 1? Yeah, sure. That's one way to say it. Yeah. So that's how we define odd numbers, if that makes sense. So you can say for then you do for j equals to 1, you get 3, j equals to 3, you get 7, so on. Right? So when we sub this in, 2j plus 1, we get 614 plus 2j. But 2j is now, it's in the form of an even number. And we know that n is an even integer. Right? So we can just substitute that for n. So this is our first value, this is our second value. All right. Leo, is that good? Sure? Okay. Final question. Can I move on? Yeah? Okay, so we have this integral here, which they've given us on Maple. Yeah? So when we integrate this function with between 9 and minus 9, we get pi. So this is pi. Yeah. And this is also pi over here. Okay. First part, give a short proof why it's neither even or odd. How do we prove if something's odd or even? Yeah. So, if it's even, yeah, over here. So, if even, if odd, all right. So these are the rules that we're following here. But in our case, we have to prove that both of them are false. Yeah. So I haven't done the proof here, but when you sub in minus x, you get that it doesn't equal to f of x or minus f of x. Yeah. So I'll do a quick proof on the. I won't do it on the board. I'll do it here. Okay, so two things I've done. Because sec h is a even function, we can just replace the minus x inside with just a normal x, okay? And same thing down here, we're just squaring the minus with the even function, right? But is this equal to f of x? It's very similar, but no. Why?
Because of the exponentials.
Perfect. Because the exponential has a power. Oh, it should be 6 here. X. Because of the exponential. Is this equal to minus f of x? Nah. Yeah? Since it's not equal to either of them, it has to be neither odd or even. Alex, make sense? Yeah? Were you able to get this? No? Did I do something wrong? Sorry? Comparing these two?
Yeah.
Oh, yeah. So we're trying to say, is this equal to 18 e to the 6x sec h? So f of x is this thing. Is what we have here equal to what we have here? Is it equal? No. Because of the e to the minus 6x. Okay? How about, is this equal to this with a minus at the front? No, right? So therefore, it doesn't fulfill this one or this one. So it's not even, but it's not odd either. Okay? So it's neither odd or even. Make sense now? Stress? That one make sense? Okay, good. Despite this result, Rory wants to use properties of odd and even functions here. So we want to decompose this into a sum of even and odd functions. Okay? So this one is purely intuitive. Right? What can we do for h of x and k of x? What options do you guys have? Is it different? Is it e to the minus 6x here? Oh, is the question different? Wait, let me take a look. Oh, do you have it?
It's just because when you expand it, one is e to the of an x plus e to the negative of an x, and one is e to the of an x minus That's very easy. You forgot it? Very good. Jamal. Sorry. Jamal.
Coding doesn't really matter. It's hard because everything just runs on VS Code.
Get ball.
So most coders actually get a Mac. You only need
So Alex, I'll do one similar to you right now.
So you're fine.
So,
And it does not take much power.
alright. So if h of
Max
x
is running on 12 frames right now.
It's meant to be about 10 times faster.
Why is it so bad?
Because my computer's like since 2016 or 2017.
No, I don't think you need a fancy laptop to code.
I'm just thinking like if I do get a new laptop, then would it be beneficial to get a bigger laptop?
Yeah, Trace, Alex, you
I'm
following?
doing civil engineering and something. I have to
So when you add these two together, what do you get?
you have to run like CADs. And it's like easier to
Do we use that?
Sorry?
In our courses,
Yeah, you just get e. Sorry, it should be 4. Sorry. You get e to the 4x, right? But what are we looking for? E to the minus 4x. So we're just going to add a negative sign here. Okay? Another property they told us is that our h of x is even, our k of x is odd. So is cosh even or odd? Cosh is even. Is our sinh odd or even? No, sinh is odd. Odd. Right? Reason being.
We just organize the group. Do you have an idea?
one box. You know the little
Oh my god.
make a sense of
But we need
yeah.
to find a supplier to do it.
That's true, but we could use the design that he has. Can you get me like
But we actually have this question, which you guys actually look cute. Like, guys.
yeah,
Oh, okay.
That would look pretty nice.
Some people,
Yeah.
but-
How's your phone?
It's like sweet, and then they're like
On the
that's
process.
what juicy is so soft. But that was the April so soft. Who cares actually? But yeah, no, 50 like literally because Mexico came away from the
Oh,
and I was like,
really?
this is actually really cool because I put on my crop and I
Yeah.
really like it.
Someone asked where they get the supplier from.
I know. Do you know what self-suck should do? In Canada, when you graduate from your GED, you get an honorary. We should do
Trace, you see that? That's how we get our audio even. Yeah, you can take a photo. Take a photo.
It is every. Oh, is it? You need to lock the building down. Bring down this. Yes, bring it straight out.
You get a
Into the bridge.
Yeah.
Yeah, you can do it that way as well. 100%. Yeah. Okay, so what I've done, so you decompose into its exponential format, which is what I've done here, and you just add them together. So in your case, your second one should be minus sine h, right? Because what you're looking for is not, it's not e to the 6x, it's e to the minus 6x. Okay. Finally, because we can break it down e to the 6x into its individual components, sine h and cos x, you can just substitute that in. So in your case, it would be cos minus alright, but in my case it's cos plus. And then you can just expand it out. These two cancel out. This is cos divided by cos. Yeah, you see that? Okay, guys, stop. What? This should be h. Oops.
I reckon Alibaba.
It's like the size of
Sine h. Alright. And sine h over cos x is what?
It has to be exclusive for
Tan. Right? It's the same thing as sine of cos.
It's like let's say like one grade.
So we're gonna break this up. Even or odd, it's even.
The ticket, yeah, because that ticket's
You can do the same way as before. Even or odd. Why is it odd?
I mean, those models are like.
This tan is odd. So in your when you write out your box, you can just say that tan is negative. Tan h is an odd function. That's all you can say. Okay, final thing. Explain why this integral is equal to pi. Put on maple. You just put on maple. So you just plug the integral into maple. It comes out with pi. Exactly pi. So you would say reasoning. Plug into maple and answer.
Can you get one too?
Obviously, you want it to be a bit more formal. Okay, you want it to be a bit more formal. Yeah, that's pretty much it. Okay. You guys, I'll give you guys a minute to copy it down. Apart from that, if you got any other questions, just come up to me. Sorry? Oh, that one other question? I'll go through it. Because that question, I highly doubt you'll get something like that. Because, but
You think we won't get something like that? Okay, then.
no, but I'll go through it anyways because it is a scene question. Okay. Did I pass it? This one, right? Alright. Are you guys familiar with induction? Induction? Your lectures? Sorry?
I don't think they class it like.
Yeah, your lectures don't go over it explicitly. They have like a small section at the bottom. They're like, oh yeah, induction, and that's it. Right? So
Maybe I'll just sort it out.
The reason I say I highly doubt you get this question is because they don't teach induction. That's why. Have you done induction before or no? Have you done induction before? Last year. So in high school? Yeah. Hey, I'll go through the question, guys. Shows. Last question. Last question. You don't want to go through it? We have to go through it. You have to do it, man. Yeah, bro. Why are you backing out? Why are you backing out? Why are you backing out? Final question. Final question. Okay. So, are you familiar with induction, Trace? Induction, right? So we have a p equals n equals 1 case. Then we have assume n equals to m case. That symbol over there is positive integers. Okay.
My tutor's notes are
And then we're proving okay?
No, there's no way.
Okay. So when we're proving the n plus 1 case, we have a r to the n plus 1 on both sides. You can just factor out an r on both sides, on each side of the matrix, okay? And we know what this is. From our assumption, we know that this is equal to s. Sorry, this is equal to s. From our assumption, okay? So we can replace this with s. We get r s r. And from our very first case, n equals to 1, we know that this is equal to s. And therefore, we prove by mathematical induction. Sora? It's something you're going to have to memorize. Okay? So, Alex, it's just a bunch of algebra. So we see, do you understand this step? Sorry?
Okay, yeah, I get it.
Okay, so yeah. So we took out that R on this side and that R on that side.
Right.
And we've seen this way from that assumption. And then we can sum it in from that assumption. Okay. This one is just a bunch of algebra. It's something you're not even meant to you can't even understand it. It's like if you see the algebra, you'll get it. If you don't see it, you won't get it. Okay? Look what I've done. S to the k minus 1. I took out an S. Are you leaving?
Yeah, I'm gonna go.
All good, man.
Thank you so much.
All good, man. I'll send out the recording tonight. Honestly, I think we can just leave it because this question's so scuffed. Like, it doesn't even make sense. Yeah?
Well, you have to just like write down the formula and like just give up.
Bro, this doesn't even have a formula. Like, this question, you write this down, and then no, this is matrices. So out of nowhere, for some reason they factored out an S, and then they multiplied by r to the a. Like, I don't get it. Like, it doesn't make sense. Okay. This one I checked it. I used check for this one, but this one I was able to do. Everything else, except for this question, I wasn't able to do.
You're not doing that.
Which math? 2018? Oh, MATH1A. I did it term 1. Yeah, last year term 1, yeah. How do I remember it? I don't know. We're done.
Yeah.
This question was so cooked. Like I didn't even go through it. No, because like for some reason they took out a S, then multiplied by a RA, then somehow this simplifies down, and then you get two different answers. Like I
That's
didn't even know
fucked.
it.
They're making up their own shit.
Yeah.
Making up their own maths rules.
Yeah. All right.
Wait, did you hit the stop record?
No, I haven't stopped recording yet. So.
It's a